In this video, we will connect data and statistics with real-world decision-making. We will look at how populations and samples work, why sampling methods matter, and how bias can quietly twist results. The goal here is not to turn you into a statistician, but to ensure that you can interpret data and research with more confidence and better business judgment. That being said, if you are using any data for any decision-making, you need to always be on alert for the statistical fallacies, which can reduce the credibility of your position or the reliability of your decisions. It is said that there are 3 types of lies in the world: plain lies, damned lies, and statistics. It is up to us to make sure we are using the truth from the numbers and not a narrative when we tell our story. A population is the entire group you care about, such as all customers, all users, or all transactions. The true characteristics of that population are called parameters, often written with Greek letters like mu, sigma, or rho. If it were possible to accurately measure every single observation in the population, we could find the exact values of the parameters. However, in the real world, we almost never know these values exactly, because the population might be too large, partly unknown, or even changing over time. This is why we collect data from samples. Samples are subsets of the population and provide measurable values. These values are used to estimate population parameters, or characteristics using hypothesis testing methods and models. So whenever you see a study result, remember it is almost always a sample, trying to speak for a much larger population. The key question to always ask is, how reliable are these results for the population I want to interact with? A sample is a smaller set chosen from the population, like a subset of customers you survey. The numbers you calculate from a sample, such as the average satisfaction score, are called statistics. Regular letters like X bar, S, or P are used to represent statistical measures. In business practice, these statistics stand in for the unknown population parameters when we make decisions. If the sampling was done well, the sample can represent the wider group effectively, and your decisions based on that data are more trustworthy. If the sampling was poor, even the most sophisticated analysis can still point your business in the wrong direction. Businesses often overlook sources of data that comprises the sample, and this can create a long-term disconnect between what one expects versus what actually happens when their decisions hit the real-world population. Don't let a sample statistic get in the way of critical scrutiny of its generalizability. Imagine you are buying a box of grapes. Tasting 1 or 2 grapes is usually enough to decide if the whole box is worth buying, because you assume the grapes are fairly similar throughout. In that case, your sample grape represents the population of grapes in the box. Now imagine picking up a box of mixed fruits and tasting only a grape from it. That taste tells you almost nothing about the apples, berries, or other fruits inside. The story is simple, but the lesson is serious. If your sample does not truly represent your population, any decisions you make based on that sample can easily be wrong. I like to call it the grape test. If all you want is the box of grapes, then sampling 1 grape gives you a good estimate. However, if you are blindly tasting a grape from a mixed fruit box, your judgment about all the other fruits becomes unreliable based on that sample. Think of an instance where a decision based on a sample estimate did not yield the desired outcome after making a decision. What failed? The grape or the fruit basket? Simple sampling is the most straightforward approach. You randomly choose some members from the full population and treat them as your sample. This works best when the population is homogeneous, meaning members are fairly similar on the characteristics that matter. Challenges appear when meaningful differences exist inside the population, such as distinct customer segments. Simple sampling can hide important patterns and mislead your business decisions in such cases. However, if you know the population proportions, you can use stratified sampling based on subgroups that comprise your population. This approach is powerful when different segments behave differently, and you need each one properly represented. In business, it helps avoid over-listening to one group while accidentally ignoring another that could be just as critical for your strategy. Cluster sampling divides the population into clusters, such as stores, regions, or teams, then randomly selects some clusters and includes everyone within them. It is often used for convenience when it is easier to study entire groups rather than scattered individuals. Systematic sampling starts from a random point in a list or flow of observations, then includes every nth case in the sample. This can be efficient when working through large, ordered data like transaction logs or membership lists. In both cases, the key business question is whether the chosen clusters or the list order are truly random or not. If not, they might hide patterns that could distort your conclusions, and therefore, your decisions. Convenience sampling uses whoever is easy to reach, the people who click a poll, walk by your table, or follow your social media accounts. Many modern surveys, especially online, fall into this category because they are quick and require little planning. However, the trade-off is often very serious. Convenience samples are rarely random and usually carry strong biases. For example, a social media poll reflects only people who were shown the poll, chose to engage, and respond thoughtfully. Convenience data can help shape early ideas or build hypotheses around them. However, it is a fragile foundation for any important changes or high-stakes business decisions. If you have ever used a convenience poll to make a decision, congratulations. You just completely misestimated what your true population cares about. When a sample is chosen with a hidden or explicit agenda, the bias built into the selection process will echo throughout the results. Self-selection is a classic example. Only people willing to respond to a survey or poll are included, which might exclude those with different views or experiences. Very small samples, especially with fewer than 30 observations, often need special treatment and may not generalize well to the whole population. As we discussed earlier, when subjectivity drives results, using those results can create fallacies and false positives that can misguide decision-makers or lull them towards complacency. Confounding variables introduce another layer of trouble, where missing factors influence a relationship and twist what you think you are seeing. For instance, studying age and weight of teenagers without considering height can easily lead to misleading interpretations. The wording of survey questions quietly shapes the data story you collect. A strongly worded or emotional question, such as labeling non-sharing children as evil, almost forces people toward a particular answer rather than capturing their true beliefs. Poorly phrased questions can confuse respondents, leading to unreliable or meaningless data. Studies funded or run by groups with strong interests can be especially risky, because their questions or sampling methods might be designed to support a preferred narrative. As a business leader or analyst, you should always look at how data was collected and whether the methodology supports trustworthy interpretation. Industry reports written by leading consulting firms might be less objective than they appear at first sight. Pick out a well-known report in your industry and scrutinize it carefully to identify what sampling methods were used. What was the sample size? Are they truly objective? Why or why not? Which of their conclusions are generalizable? Do you use correlation when you actually mean relationship between two variables? Correlation is a statistical term that measures strength and direction of a linear association between two variables that may or may not be related to each other. Thus, an existing correlation does not establish a relationship between the two variables. Consider this sentence. Every time I visit a city, it rains there. This type of association creates what is called a spurious correlation. The data might appear to show a pattern, but are meaningless from a real-world perspective. In business communication, people sometimes tell confident stories that turn these patterns into causes, even when the true data does not support that claim. Your role is to pause and ask whether there might be other explanations, missing variables, or simple coincidence driving the pattern before acting on it. Remember, correlation does not imply any causation. Throughout this presentation, we treated statistics as a way to tell careful stories about larger populations using smaller samples. The strength of those stories depends heavily on how the sample was chosen and whether it truly represents the people or items you care about. Bias can enter through sampling, question wording, self-selection, or confounding variables, and it will quietly shape any conclusions that follow. As you evaluate reports, surveys, or dashboards, ask how the data was collected, how representative the sample is, and whether the claims of a relationship are justifiable. Using that mindset will help you turn statistics into clearer, more honest business decisions, rather than misleading narratives.